The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to today's OpenStudio Overview webinar, where we'll be covering OpenStudio version 1.4.0 new features. My name is Chris Balbach. I'm the Vice President of Research and Development at Performance Systems Development. I'll be leading the webinar today, and I'll be assisted by my colleague Alex Lavallo, who is a Building Performance Engineer here at Performance Systems Development. So today we have about an hour to go through a combination of some slides and some live demos of OpenStudio version 1.4, and I encourage us to make this webinar as interactive as possible. So I'd like to ask you folks out there that if you have questions during the webinar, if you go ahead and enter them during the questions pane in the GoToWebinar interface, and my colleague Alex will address as many of those questions as possible given our 1 hour time constraint today. So again, I would encourage you to ask questions as they come up. Due to the large number of participants on today's webinar, I'm going to have to mute all the attendees, so the questions pane will be the way that you can interact with us. So I'm going to start the webinar today with just a broad overview of the history of energy simulation programs, a little background for why we're here. And this slide, I like this slide a lot. It was taken from a thesis statement by a good friend of mine, Jeff Haberl, one of his students, and it shows the history of energy simulation here in our country. And it starts off in the mid-60s. You'll see on the left axis of the time series chart. That's really when this business really started. And as you go over toward the mid-80s, and I only took a portion of the slide out of the thesis, you'll see some names you might recognize, like DO2, Blast, Trace 700, and so forth, or Trace, for example, and you start to see where these programs came from. And what you'll start to realize is that largely in the energy simulation community, we haven't had a lot of innovation. We're using a lot of the same things that were developed in the mid-60s, enhanced through the 70s and the 80s, and that's kind of where we are today. OpenStudio is different, and what I'm going to introduce to you again, OpenStudio 1.4, is very different in the sense that it's going to allow us to innovate in a way that we haven't been able to innovate with energy simulation software in the past. There's three real reasons I would say that we're even interested in innovating. One would be, frankly, to just differentiate ourselves from our competitors. The second would be to outcompete our competitors, better, faster, cheaper. And the third would be to enter new markets. How do we find ways that we can use energy simulation to enter markets where it's currently not feasible? So keep that in mind as we're going through the webinar today, of how, again, OpenStudio could provide some pathways for us to do things that just really weren't available, weren't possible in the not that recent past. So the next slide I have here today is a slide that shows what I call the energy modeling ecosystem, which includes OpenStudio. If you look to the right of the slide, you'll see sort of a hub-spoke arrangement. In the center of this arrangement is the OpenStudio SDK. To the right, you'll see some OpenStudio user-facing applications, the PAT spreadsheet, the SketchUp plugin, the application, and PAT itself. Those are the applications we'll focus on today. I do want to point out that there's a number of other applications that are being built on top of the OpenStudio SDK, and that really makes it different from some of the other engines that you may have seen in the past. There's really three unique things about OpenStudio that I would emphasize here. Number one, it's open source. Any and all of the code related to any of the user-facing applications, as well as the code itself, is freely available to the community. It's also cross-platform, so the OpenStudio ecosystem can operate on Linux systems, on Mac systems, on Windows boxes. The same file can be shared across all three of those platforms. And third, and most importantly in my opinion, is it's collaborative, meaning that we have a number of different members of the community who are contributing to the OpenStudio ecosystem and the development of that ecosystem. And those would be national labs such as NREL and LBNL and Argonne and so forth, but also private sector companies. You'll see here again, a great example of that would be Simuwatt, which is a private sector company developing a simulation platform based on the OpenStudio SDK. There's a number of others here under the top secret category, other companies working in parallel who are developing, again, on top of the OpenStudio ecosystem. And really what I want to point out from this slide is that OpenStudio represents what I call a pathway for innovation to occur. So what we'll see in the next few slides again are examples of how it comes down to, for me, better, faster, cheaper. How people are accomplishing their energy modeling tasks and their workflows that they're using in a quicker and a higher quality and therefore less expensive manner. The other 2 things I would point out on this slide is you'll see the OpenStudio icon here in the center, the blue cube. You'll see underneath it the engines that OpenStudio supports. That's not just Energy Plus, it's also ESP-R, it's also Radiance, and it's also Contam. And you'll also see 2 other things here, the Building Component Library and TPEX feeding into the OpenStudio core. So we're not going to talk a lot about those today, but just to point them out to you, that the TPEX, which stands for the Technology Performance Exchange, and the BCL, which is the Building Component Library, they are 2 separate systems that feed data into the OpenStudio ecosystem. And those systems are simulation agnostic. They've been designed to support OpenStudio, but they can also be used for other simulation engines as well. So here's a bit of an agenda for what we'll cover today. Again, we will go through a series of slides covering OpenStudio's 1.4.0 new features, and then we'll demonstrate those features in a live environment. Those features would be the changes to a new OpenStudio workflow. Apply Measure Now is what we call that workflow. New templates for OpenStudio, which incorporate compliance objects, such as compliance with ASHRAE 90.1 2007 and 90.1 2010. Some new HVAC objects included in OpenStudio 1.4, and these are unitary HVAC systems, which include the ability to humidify or dehumidify, have control for humidity. We'll explore a configuration of primary and secondary piping and pumping configurations. We'll explore the PAT spreadsheet export, which feeds into the OpenStudio analysis spreadsheet. And then finally, we'll close with some expanded measures that are included in the Building Component Library and now accessible through OpenStudio 1.4.0. So let's start off with the Apply Measures Now feature. And the Apply Measures Now feature is a new feature for 1.4. It's unique in the sense that what it allows an OpenStudio user to do is to do what I call inject a measure, inject an OpenStudio measure into the model. And that's into the model while it's in the OpenStudio application. So previous to release 1.4, users had to actually simulate a model in order to run a measure or execute a measure. And a new feature in OpenStudio 1.4 is that we can apply measures now. So literally we can change our model on the fly, rapidly modify our model without requiring a simulation execution. And that's going to open up a lot for us. It's going to let us now start to think about measures in a completely different way, where we can think about chaining measures together. Say one measure feeds into another, which feeds into another, and that will help us articulate a model quicker and cheaper and faster and with higher quality. So here's an example again of the OpenStudio application interface for the Apply Measure Now feature. And it's important to point out that there is a method for undoing a measure, so we can apply a measure, we can see if it works, and if we don't like that, we can undo it. And that's a rare feature in OpenStudio. There actually is an undo feature for applying measures now in the OpenStudio application. So we'll see again, after we get to the slides, we'll do a live demo of a couple of those just to demonstrate how the Apply Measure Now feature works. But I would emphasize again that this is an opportunity to change the way that we build models. We might, for example, have a measure that creates some geometry, and then we have a measure that assigns some properties to that geometry. Then we have a measure that assigns some HVAC systems, or maybe creates some thermal zones for that geometry, and so on and so forth, where we're stacking these measures together to automate the creation of a model. That's a very unique way to improve our modeling workflows. So the second new feature I would talk about today for OpenStudio 1.4.0 is extended OpenStudio templates. And the templates are located in 2 different places. They're located both within the SketchUp plugin and also within the OpenStudio application. And in the past, we had templates. Templates is not a new feature. It's the extension of templates. So prior to version 1.4, there were templates available for these 4 types of buildings. ASHRAE Standard 189 are DOE reference buildings of 3 different vintages. And those templates were again broken down by climate zone and also by sector. For OpenStudio 1.4, we have a new set of templates which address 90.1 2007 and 90.1 2010 compliance objects. So as an example of that, you'll see we use the term resource objects, and that's really what we mean by what these templates incorporate reusable objects, which are referred to as resources. All of these objects that are in the list on the left are included in a compliance set, such as ASHRAE 90.1, 2010, or 2007. So essentially what we have with this feature is we've taken the classic paper version of ASHRAE 90.1, 2007, the tables that are included, for example, Table 5, which has different climate-specific tables of minimum compliance performance specifications for envelope, forming fabrics, roof, walls, above grade, below grade, and so forth. All of that knowledge has been taken and transformed into OpenStudio objects that can be very easily applied, very easily attributed to building form and fabric. And now not just the objects themselves, which are referenced in ASHRAE 90.1, 2007, but also a number of what are commonly called unregulated loads. And the examples of unregulated loads would be things that 90.1, 2007 just flat doesn't address. So those can be things like people density, occupant density, plug load density. Plug loads are unregulated in ASHRAE 90.7, 90.1, 2007. So we have now at our fingertips new templates for ASHRAE 90.1, 2010, and 2007 that also bring in reasonable values for those unregulated loads. So again, we'll see an example of that. What that's going to let us do is very quickly build a building form and fabric and start to assign these templates to our building form and fabric and very quickly build a baseline building, a compliance building, if you will. I threw up on this slide just a map. It was accurate as of July of 2014, which states use which code as far as its compliance code. So you can see here again a large portion, there's 32 states right now that are referencing ASHRAE 90.1, 2007 or 2010 as the minimum baseline for energy code compliance. So again, we have a large set of the country that is applicable for very rapidly building baseline code compliant buildings, which of course then we want to explore beyond code with. So the next feature I'll show is the feature of new unitary HVAC systems. And you'll see at the top of this slide, what we're talking about here are the typical package rooftop units that are so popular in the United States. And I've broken these unitary systems down a little bit, starting from left to right, the very simplest systems, which are simply heating only, whether it's gas or electric heat. Then we have a bit more complicated. These are unitary systems that have split DX cooling, including gas heat, or split DX cooling with electric reheat. Then as we move to the right, we see some more complex systems, unitary two-speed DX cooling systems with either gas or electric heat, and so on and so forth. So these are packaged systems, we're commonly referred to as packaged equipment. And a unitary system is simply a combination of a fan, a cooling source, maybe a coil, a heating source, maybe a coil or a furnace section, maybe a reheat source, maybe a preheat coil. All that is combined into a single packaged piece of equipment. And it's really combined so that it can be applied very simply and installed simply onto, say, an existing curb. In OpenStudio, it's very simple to apply these new HVAC systems. It's basically create an air loop, find the right unitary system, drag and drop that unitary system into the air loop on the supply side and configure that system. And then finally, optionally, item 3 there, add outside air management such as economizer controls, and optionally add energy recovery, whether that's sensible or total energy recovery, to the unitary system. So these systems are very commonly found, for example, in residential applications where they may not have outside air management systems, it may just be pure recirculation systems, but also very commonly found, again, in any type of package rooftop configuration, along with some economizer configurations and perhaps energy recovery. So again, we'll go through the application of those unitary systems with an example toward the end of the webinar. The next feature that it was released as a part of OpenStudio 1.4 is the ability to model primary and secondary piping and pumping configurations. So for those of you who aren't familiar with primary, secondary piping and pumping, I have on the top right of this slide a simple diagram that shows a bank of boilers, modular boilers, and each boiler has a pump. And the purpose of that pump is simply to drive water through that boiler and inject it into the primary loop. So that's called a secondary pump. And again, that secondary pump is responsible for moving fluid, moving water through the boiler and injecting it into the primary loop. There's 5 of those modular boilers, 5 of those secondary pumps, and there's 1 primary pump in this situation. The primary pump in this situation is also known as a distribution pump, so it will be pushing the water out through the terminal units, through the coils, through the radiators, whatever it would be, out to serve the thermal zones of the building. So that's very easy to model in OpenStudio, this type of configuration. You'll see that the way one would model this, if you stay to the right, the bottom right of the slide, one would build a plant loop, and they would put a pump on that loop, as you see to the top left of that diagram. That's the secondary pump. They would add a boiler. That would represent one of the modular boilers. They would add a set point controller that would tell that boiler again, are you operating on some kind of constant temperature control or some sort of reset temperature control or what have you. And then on the demand side of this loop, you'll see they would add what's called a fluid heat exchanger object, and that's a new object for OpenStudio version 1.4. So that's this object here on this plant loop. So the user would then add 5 of those loops, create 5 duplicate loops, 5 secondary pumps, 5 boilers, 5 controllers, and 5 fluid heat exchanger objects. And then to complete the design in OpenStudio, the user would create a 6th loop, a 6th water loop. And in that water loop, they would assign the 5 fluid heat exchangers. It's the opposite side of the heat exchangers. So this represents the distribution loop, or the primary loop. So yet again, it needs another pump. It has the supply coming from the fluid heat exchanger. It has another set point controller telling that distribution loop, what are you trying to do? Are you trying to send constant temperature water through that loop, or some sort of reset through that loop? And then, of course, the loads. So in this case, to keep the image small, I just had 1 load, but you could have many, many loads. OpenStudio is very flexible in its configuration for primary and secondary pumps. You can have as many primary loops as you need, as many secondary loops, multiple secondary, and even tertiary pumping. So that's a very powerful feature, again, for modeling real-world systems, whether they be hot water, as this example, or chilled water, or perhaps even condenser water. So the next feature I would like to introduce is the OS analysis spreadsheet. And I'll just warn folks right now, this is an advanced feature. There's a great deal of knowledge that needs to be foundational, fundamental knowledge before you really access this feature. But I will talk a little bit about it and explain a little bit about what it can do. So the OS analysis spreadsheet is a standalone spreadsheet. It's in a Microsoft Excel .xlsx file. And that file is available for anyone to download. It's available from the NREL GitHub repository. I've put the link here. And by the way, this webinar will be recorded, and so these slides will be available on our website in a day or two. So if one would follow that link, they can download the OS analysis spreadsheet. And this spreadsheet is really meant to be an example of an alternative interface for the parametric analysis tool. It's meant to be an alternative interface running PAT on the cloud. So it really is meant to drive OpenStudio analysis through the Amazon EC2 cloud using high-performance computing resources. Now this spreadsheet, I've taken screenshots of 3 of the different spreadsheet tabs. The spreadsheet has 3 tabs. One is a algorithm setup tab, another is a parameter space setup tab, and the 3rd tab is an output setup tab. So those 3 tabs need to be populated in order to drive the OpenStudio PAT on the cloud analysis. And what we get with the PAT spreadsheet export is that we can set up our run actually in PAT and then export from PAT, the PAT tool, CSV files that can then be cut into and pasted into the OpenStudio analysis spreadsheet, those 3 tabs that I showed a moment ago. So this is a very, very powerful feature for advanced simulation studies, and what it lets us do is it lets us define and configure an optimization algorithm. There's a number of algorithms, optimization algorithms, that are supported by OpenStudio. Some of those use genetic algorithms, some of those use, again, 4 or 5 of them right now that are supported. We can select those using the spreadsheet and configure them. We can then define and configure our objective functions. That would be another way of saying what the purpose of the simulation study is. Is that to, for example, minimize life cycle cost? Is it to minimize carbon emissions? Is it to perhaps match up to an annual energy use for a calibration objective function, or to perhaps match up to monthly energy use as an objective function. And then the third tab again to define the distributions of input parameter space. So that would be what parameters are we allowing to change and how are we allowing them to change. We call that the parameter space. That section, define the distributions of the PAT spreadsheet feature. So again, I will demonstrate this during our live demo, but suffice it to say that this is a very advanced feature for folks who want to conduct a simulation study, and they want to use cloud resources to do it, and they want to cover a large input parameter space, but yet not run a brute force analysis. So that would be the PAT spreadsheet export. So the last feature we'll talk about before we go to the demo is expanded BCL content, and in particular, the expanded BCL content is both in components and in measures. OpenStudio version 4.1 and the latest version of the building component library now contain a new set of measures that represent the AEDG, that stands for the Advanced Energy Design Guides, both the K through 12 and the Office AEDG guides. So some of you might be familiar with these guides. I took some screenshots at the bottom right of the slide showing the AEDG guides for both the medium office, small medium office, and K through 12 buildings. These are prescriptive guides. If you want to think of them as very simply and boil them down, they are prescriptive cookbooks for how one might achieve near 50% reductions over a code component for their climate zone and of course K through 12 or office buildings. So what we have again now in the BCL, the Building Component Library, is we have these prescriptive guides, these several hundred page PDF documents coded as OpenStudio measures, and they're simply drag and drop and apply, run them. So very quickly one can take their code compliant building, say their ASHRAE 90.1 2007 compliant office building, and literally apply the AEDG office measures and predict the energy performance as well as the energy cost performance of achieving measures that are in line with the AEDG small and to medium office building. So that's a very powerful feature. You'll see, I pointed out at the bottom of this slide, the link to the OS OpenStudio Measure Roadmap, which the strength now that we have the Apply Measure Now capabilities to modify our model in near real time. The strength now really turns to leveraging measures, and as we see more measures get contributed to the Building Component Library, I believe we'll start to see those measures being very valuable for very quickly building up a model just by stacking measures. So I'm going to break now. We'll go over to the SketchUp plugin and we'll do live demonstrations. So we will start today with a demonstration of the Apply Measure Now feature. And to do that, I'm going to go ahead and launch the OpenStudio application, version 1.4, and I'll load a sample file that we can work with. So I'm going to open up a file that actually has been built and has some form and fabric in it, and then we will articulate that model further. Okay. Just one moment while I open the file. Okay. And I'm opening up this model again, Studio application. And the first demonstration I go through is the Apply Measure Now demonstration. So the Apply Measure Now feature introduces a new item into the OpenStudio menu. I'll wait for a moment as this file loads. Okay. it is a large model, so it might take just a moment to load up. Okay, so if you're seeing now, if you're caught up, see a new item in the menu here, which is Apply Measure Now under Components. I'm going to Apply Measure Now. So what that will do is it brings up a screen showing me the measures that are. So I would go to the opaque section. I would take a measure that already exists. It says set R value of insulation to roofs to a specific value. I will configure that, and I'm going to make it R50. And I'm going to leave cost out for the moment. I'm just going to apply the measure. And when I do that, OpenStudio is executing the measure, checking to make sure it's going to run correctly, and it gives me some feedback. It says, okay, you started out with a compliance roof, something like R20 in my climate zone, and I've changed it to R50. And it tells me again what exactly changed. In particular, there was this roof construction that was altered. The important thing is I can either accept those changes or I can reject them. I'll go ahead and accept the change. And I've literally changed my model. So I've just physically changed the definition of my model. Now there's one other feature that's in the Apply Measure Now that's definitely worth sharing, which is the revert feature. So maybe, you know, I made a mistake. Maybe I actually, I did choose to accept that measure, but now I've changed my mind. I have one more chance to revert to that. And under the File menu now, there's the example to revert to save. So until I save again, I could always revert back to my last model, which has the pre-measure configuration. So that's the Apply Measure Now feature demonstrated. Now, Apply Measure Now, again, I would just say it can be very powerful because one can't imagine just getting some framework and then start building off of that, start attaching measures in series. Okay, like what do the walls need to be? What do the roof need to be? What properties of the windows need to be? And just incrementally improving the model using measures and not the OS interface at all. So that's a new way that the OS application can be used. So now I'll go ahead and demonstrate the OpenStudio templates. And to do that, I think I'm going to open up the SketchUp plugin. It might be easier to do that. So I'll open up the SketchUp plugin that's associated with OpenStudio version 1.4 to show again that I have OpenStudio 1.4 loaded here. And I will get rid of Susan here, and I will map it by first loading a template. And let's just say, for example, let's take the office template. So I'm going to open that up in Notepad just so you can see what's in that. This is just a text editor, Notepad++. And I'm going to search for the texturing 2007 here. Oops. Excuse me for a moment. Let me see. Oh, I'm in a. There we are. Okay. So you'll see here a number of highlights on 2007, and these are. I'm looking right now at the template for the Office template for OpenStudio 1.4, and it includes again objects that are adherent to 90.1 2007. And let's just go scroll through a few more of these. So you'll see here's an example of a lighting definition for a closed office space type at 11.84 watts per square meter. And that should be adherent to that. If you were to open up the 90.1 2007 PDF edition and search and look in Chapter 6 for lighting and find the table for that, that should match. So all of that again has been encoded into this OpenStudio template library. An example of something that's not it's an unregulated load. So here's an example of a people definition. So here again, I've highlighted it. Is a 90.1 2007 office closed office people definition, 0.051 people per square meter. That is an unregulated load. You'll never find that in 90.1. No one will ever tell you what the people density should be. However, this is coded in here, so this is a good default for that. You'll find schedules as well. You'll find objects that were on this previous slide are in here as resources. Use the OpenStudio Inspector tool and I can see it in greater detail. It's another way to see. To 90.1, not just 90.1 2010, but also other 8189 and so on and so forth. They're all in here. And that again, the importance of this feature is that I can apply these resources to building foam and fabric very quickly to start with a minimally code compliant model. And that's the takeaway of this feature. Okay, so let's go talk about the next feature, which is the new unitary HVAC system. So I'm going to go back here to the OpenStudio application. I'm going to save this model off so I don't destroy it. There's a new name, and then we'll add some HVAC systems to it. Okay. And again, I apologize, I'm running on a laptop for this web. See if I can get this to save quickly. Okay. So the unitary HVAC objects can be found in the HVAC template screen of the OpenStudio application. As soon as this finishes saving, we'll be able to maneuver to that. And what we'll see is a drop-down list, there it refreshed, toward the top left in the library, where I now have a new air loop HVAC unitary system collection of objects. So you'll see here a large number of objects, I think it's like 15 or so. And the way one would apply these is they would first go again and they would create a new empty air loop. And then they would select the unitary, let's make a very simple one here, it's just a gas heat, and drop it onto the supply side of that air loop. And I would create a new object here, which can be configured. And just like other OpenStudio objects, when you select it, on the right, you can now edit the parameters or the attributes for that object. Most importantly, the controlling zone. And I have 3 zones in this model. Let's just say it's RTU1. The availability schedule, whether it's available to run only during the summer or only during the winter, and so on and so forth. And then finally, you'll see, as you scroll down, all of the objects that are contained in this unitary equipment. You remember how I said a unitary piece of equipment includes a fan. It includes the performance curves for that fan. Again, another performance curve for the fan. It includes some, in this case it's a very simple, there is no cooling coil, it's just a heating. And in this case it's a furnace. So this unitary object contains all of those parameters inside it as a single object. So from that point of view, now it's very simple. All I would do is add thermal zones to my model, and I've configured a very simple unitary type system. So this unitary, even though I have 2 zones here, that RTU1, I also have RTU2. I can again configure it so that RTU1 is driving the bus, so to speak, and but yet supplying conditioned air to RTU2 zone as well. So very simple to configure the unitary systems. The other thing that the unitary systems allow, and it's new in OpenStudio 1.4, is if we go to the thermal zone screen, we now have the ability to specify humidity control. I mentioned that in the slides earlier. Those are only available for zones that are controlled by unitary systems right now. So we can define a humidification set point schedule or a dehumidification set point schedule, constant humidity control. And as long as this zone, like RTU1, is controlled by some piece of unitary equipment that's capable, has reheat and so forth, so it can do dehumidification, it will operate the equipment with that sequence of operations. So that's a new feature for OpenStudio, allowing us to have humidity control in zones as well as just simple temperature control. So that's really our introduction to the unitary HVAC system objects. And I think I'll go on to the next feature, which is the primary and secondary plant and pumping and configurations. So for this one, we'll need to create a new blank plant loop. And let's just go ahead and build the model that was on the slides. I don't know if you can recall, but there were 5 boilers that were in parallel, banks of small, say, little condensing boilers. So we'll build the first one. And that would be very simple. We have our air loop, our plant loop. We would need to drop a boiler into that loop. So that would be under boiler hot water. We could again configure that boiler to be condensing or not condensing and so forth based on its efficiency in the part load performance curves. Which would be the fluid-to-fluid heat exchanger object. And that's down here, heat exchanger fluid-to-fluid. And we would now drop this again on the demand side. So we'll drop it on a demand side. And finally, we need a pump. In this case, we'll put a constant speed pump into our system. And then finally, the last thing we need is some sort of set point controller. This, we can make it a simple set point controller, just a schedule controller. Say we want this boiler to deliver 180 degrees, we would make a schedule for that. We would drive it for 180 degrees anytime this equipment is enabled. May not get there, may not have the capacity to get there, but at least it would be the attempt to control that boiler to 180 degrees with constant flow control. So now we have our what the slide called the secondary loop. This is our secondary loop. Let's make one more, and we'll name this boiler bank number 1. And let's make another boiler identical. And so again, putting in a temperature controller, a fluid heat exchanger, a pump, and a boiler. And again, okay, so this would represent our second boiler. And again, we'd have to configure these. I'm going through it rather fast. We have to configure the pump head, the pump efficiency, performance curves, and so forth, also for the boiler. Let's name this boiler bank number 2. And now we would create our third blank empty plant loop. And on the supply side of this loop, we are going to not use, we're going to use what's in our library. We're going to use the 2 heat exchangers. They are supplying our distribution loop. And again, we need to add a pump to this loop. Let's say it was a constant speed pump. And then we would need to add some loads. And let's see if I have any coils here that I don't have any in my model right now, but we would again drag our heating coils and just drop them into the demand side. So that would be the definition of primary, secondary heating control. And oh, we need one more thing here. We would also need to put in a set point controller to tell this loop how to operate. So again, just a scheduled set point, whether that be a reset or whatever it might be. So that very easily lets us configure these plant objects to represent real-world configurations that we see both in new construction and retrofit scenarios. So that's a demonstration of our primary and secondary piping and pumping configurations. And again, there's a lot of configuration settings within these objects. And I would refer back to the Energy Plus documentation for understanding exactly how to set these settings. For those of you who aren't aware, there's the our friends at Big Ladder have put OpenStudio have put Energy Plus documentation online in searchable hypertext language. So that's the place I would go. If you just go to Big Ladder Energy Plus documentation, you will find the links for the online, not just the source code, but the online documentation as well, and you can search that to find out exactly how these objects work. So here's the fluid-to-fluid heat exchanger. If I were to just again search for fluid, here I'm sure I will find this object. There it is, heat exchanger fluid-to-fluid, and I will find the gory detail, the input fields for this object that I would then configure here in OpenStudio. Okay, so that's the primary and secondary configuration. I'll go on to the next feature, which is the OS analysis spreadsheet. And for this, I'm going to have to open up another tool here, the parametric analysis tool. So let me take a moment here to clean up the desktop a bit. I'm going to just one moment here. I'm going to go into the parametric analysis tool and open up an existing project. So I'll go here to my let's go to this guy. That'll work. And load up a PAT project that I believe has been completed. And you'll see here that PAT version 1.4 now has this new export analysis spreadsheet item in the menu. And that's the new feature. And basically, in order to have that, we'll need to run the baseline model. And we'll need to load the seed model. So actually, let me open up a different project here that I know is finished. Just a moment here. Okay. And while I'm doing that, I will show you the spreadsheet, the analysis spreadsheet. And that is under okay, so if you go to the GitHub account, like the link that's suggested in the slides, what you'll do is you'll download, actually I'll just show you how to do it, it's probably easier to show. One can go to GitHub, okay, and you can go to the repository in the GitHub. It's called an OS analysis spreadsheet. You can download the latest release, 0.2.4 pre-1 is the latest release. So you download that as a zip file, and when you unzip that, you'll get this collection again here of files. And also underneath this, you'll see instructions. So if we go here to 2.41 and click on it, we'll see detailed instructions on how so it can access your Amazon EC2 account, the privileges for your keys, your private keys and secret keys and so forth, as well as installing some really specific bundled items. So those are all here again. Once you've done that, you'll find this directory tree, and if we go into this directory called docs and we go into the template input, it's an example template, we will see the sample spreadsheet. And you'll see here again the spreadsheet has variables as a tab, has outputs as a tab, and it has setup as a tab. Those are the three tabs again that we will use as configuration. There's also an instructions tab. So in the setup tab, one can choose again the type of analysis that you're going to perform, whether it be a genetic algorithm or a Latin hypercube or just a brute force search and so forth. And also, depending on that selection of algorithm, how you're going to configure the initial settings for the algorithm. The variables tab is the parameter space. So that's again, what kind of parameter space are you considering exploring? This is the tab that PAT will export, okay, that we will cut out of PAT and paste into this sheet. And then the outputs tab would be our tab here for the objective function. What are we trying to accomplish with this simulation study? Are we trying to match some value? Are we trying to run brute force, so on and so forth? And this again, we cover this in our OpenStudio trainings, how one would set this up for different use cases, such as a calibration study, such as a minimized life cycle cost study, such as a minimize emissions, so on and so forth. The BCL measure data is just a blank tab where you can cut data into other tabs. It's not used in the analysis. So this is the OpenStudio analysis spreadsheet, and then again, now that we have PAT that's loaded up here, we could simply export the analysis spreadsheet from a completed PAT configuration, and that would give us a CSV file. It's exporting it right now that we can paste into this spreadsheet And that will greatly streamline our results if we're going to have to set up again, a large-scale simulation study, which OpenStudio, by the way, very well, you can run hundreds, if not thousands, of models in a number of hours because we're running them in parallel using the Amazon EC2 cloud resource. And don't be afraid of that. Some people say, well, that must be very expensive, or that must be very difficult. Or actually, it's not. It's not expensive. It costs about less than $4 to buy 16 cores for an hour. So you can run, if your simulation requires a half an hour, you're running 32 simulations for about $3.90, something like that. 320 simulations for $39, scales like that. Anyway, again, we cover those sorts of simulation studies in our training courses, but don't be afraid of them. It is sort of the way that simulation is moving, where we're performing a very detailed study and we're examining a large parameter space for that study. So that was that feature, the PAT spreadsheet export feature. I'd like to go now to the expanded BCL content. And to do that, I'm going to go over to the BCL website. So anybody who searches for NREL BCL will be led to this site, which is the Building Component Library. And on that library, one can apply for an account, a free account. And that account would be linked again to your SketchUp and your OpenStudio application, your SketchUp plugin, such that you can retrieve these measures directly into your OpenStudio models. So there is a measure category here in the Building Component Library, and you can see right now we have a number of measures that are here in the public domain. Let me just look here. I think we have, 125 as of today. Lots of HVAC measures, lots of envelope measures. I'm going to drill down and look at the whole building measures. And let's look at whole building space types as just an example to show you again. That was not where I was looking. I'm looking for the AEDG measures to show you examples of how powerful and comprehensive they are. Here we go. So we have some here. The AEDG office air source heat pump with DOAS, office fan coil DOAS, office radiant, and office BAV with chill water cooling. So these are 4 measures that exist in the AEDG. We could go look them up, chapter and verse. We could read about them. We could try to input them manually into our model to approximate AEDG performance. Or we could just simply download the measure and apply it. The unique thing about these measures, and I'm just going to look here, I'll take the ground source heat pump as an example. They are large template measures. And again, remember the thing about OpenStudio, it's all open source, so all of this is open for us to investigate what's really happening here. We can download the measure code and copy it, make it ours, so on and so forth. This measure is very unique in that it automatically applies a ground source heat pump system to a K-12 design. Let me go back to an office. How about this office VAV with DX cooling? The very unique thing about the AEDG measures is they have no arguments. And I'll just show you this as an example. If I go over here to PAT, Parametric Analysis Tool, let me blow up the screen a little bit. I'll go over to the point where I pull in my measures. And I'm going to create a new measure here, HVAC. And let's pull this over a bit so we can see it. It's the whole system. And you recall we just looked at it just a moment ago, the HVAC office with DX cooling. I'm just going to drag that in and make a new measure group. And that's fine. I'll destroy my results by doing this. That's okay. My point on this is to show you how these... Oh, not sure what happened there. Okay, let's close that out. My point here is to show you that these measures, when you drop them in, require no configuration. They're pre-canned. They're measures that come configured to the AEDG prescriptive guidelines. Now, remember how we had the Apply Measure Now feature. It would be very easy for me to apply one of these AEDG measures into my building initially, very early on, and that would give me templates for having a ground source heat pump in my building, or having a radiant cooled system in my building, or having, whatever. And having that compliant to the AEDG guidelines that I could then transform and make them to whatever level I'd like. So just to show you that again, I can just open up the OpenStudio application, and we can apply that measure at any, we do not have to simulate the model, we can just use it again to change the model that we have. That's a very, very powerful feature, combining the this new apply measure now with very innovative measures in order, again, to get the type of model that we want. Okay, so let me go on now back to the slide deck. I've shown all of the measures and the features for OpenStudio 1.4 that I'd like to. I just want to talk a little bit about what's coming up next. And here at PSD, we do these types of webinars, new feature releases. We've done this one for 1.4, one for 1.5.0. We do have a number of other free webinars. We had a few last week. We have one coming up on August 14th. Again, a sneak peek into OpenStudio. And we also have training courses. So I do want to point out that we are offering, in the state of New York, we have a very gracious subsidy for OpenStudio training courses. And folks who qualify for that subsidy would be folks who participate in the NYSERDA systems benefit charge. And whether or not you qualify for that subsidy, we do have a number of classes scheduled in New York State over for the next 2014 and 2015. The next 3 that are coming up are in September, October, and also 2 in October. So consider those classes if you'd like to learn more about how to get dirty, really get hands-on at learning how to use the OpenStudio user-facing applications as well as the analysis spreadsheet and the cloud computing capabilities. We also have some classes that are not here in New York State. We're teaching a course as part of the Energy Modeling Conference, ASHRAE BPSA Sim Build on September 9th, and that class will focus on measure authoring. So we'll be handing out a lot of example measure code, both OpenStudio, Energy Plus, and reporting measures, and that is just a one-day course. Again, it's September 9th. You can sign up for that on our website, psdconsulting.com/training/New York State trainings. And we also have a class scheduled on the books in Washington, D.C. in December, and that will be a 2-day user-facing OpenStudio class as well. So as OpenStudio support consultants and training consultants, we at PSD like to support people who are thinking about converting from their existing workflows, whether you're using an existing interface, Trace 700, eQuest, Carrier HAP, whatever it is. We would really like to be there to support folks when they're considering making this transition. And sometimes that means things like just holding their hand, helping them with API assistance, helping them with consulting for particular models that they're trying to work their way through as they're making the transition, or even helping them with setting up hardware for accessing high-performance computing resources and things like that. So we do at PSD provide those services and more, and if you are in an organization where you're considering making that jump from your existing simulation platform to the OpenStudio suite of tools, please consider reaching out to us for help if you hit a wall where you might need your hand held for a bit. So I'm going to, that's the end of our slide presentation. I'm going to see here, it looks like I have a few more minutes left. No more questions left? Okay. I'm just reviewing the questions that came in for a moment, and it looks like we have many of them were answered during the presentation. So I will remind folks that this presentation is being recorded. The slides will be available. They'll be posted on the PSD website, the psdconsulting.com/trainings website. And please do be in touch. We'll be having the next webinar in approximately 2.5 months, something like that, for the 1.5.0 new features. So happy modeling, and I hope to talk to you and work with you in the near future. Take care, everyone. Bye-bye.